Myself Pooja Patil. I got the assignment topic determination of barium as barium sulfate gravimetrically method. Introduction. This is a quantitative analytic technique used to determine the amount of barium ions in a solution by precipitating it as barium sulfate, which is then filtered, dried, ignited and weighed. Principle. Barium ions are precipitated from a solution as barium sulfate by adding a dilute sulfuric acid or sulfate solution, example ammonium sulfate. The precipitate barium sulfate is sparingly soluble in water and dilute acids, making it suitable for gravimetric estimation. The precipitate is filtered, washed, ignited to constant weight and weighed. From the mass of barium sulfate, the amount of barium or barium compound can be calculated. Why barium sulfate used? Because it is a highly insoluble, forms a pure stable compound, unlikely to decompose on heating. Reagents required. First one barium chloride solution, second one dilute sulfuric acid or ammonium sulfate, third one distilled water, fourth one dilute hydrochloric acid HCl for washing. Principle. Barium ions are precipitated from a solution as barium sulfate by adding a dilute sulfuric acid H2SO4 or sulfate solution, example ammonium sulfate. The precipitate barium sulfate is sparingly soluble in water and dilute acids, making it suitable for gravimetric estimation. The precipitate is filtered, washed, ignited to constant weight and weighed. From the mass of barium sulfate, the amount of barium or barium compound can be calculated. Why barium sulfate used? Because it is a highly insoluble, forms a pure, stable compound, unlikely to decompose on heating. Procedure. First, preparation of solution. Take a known volume of barium chloride solution in a beaker and dilute it with distilled water. Second one, precipitation. Heat the solution to about 70 to 80 degrees Celsius. Add a dilute H2SO4 dropwise with constant stirring until precipitation is complete. Allow the mixture to stand on a water bath for about 1 hour to make the precipitate crystalline and easy to filter. Third one, filtration and washing. Filter the hot solution through a previously weighed sinter glass crucible or Whatman filter paper. Wash the precipitate several times with hot distilled water containing a few drops of dilute HCl until free from chloride ions. Fourth one, drying and ignition. Dry the precipitate in an oven at 110 degrees Celsius. Then ignite gently in muffled furnace about 800 degrees Celsius to constant heat. Cool in a desiccator and weigh. Calculations. Barium plus sulfate is equal to barium sulfate. Molecular weight of barium sulfate is equal to 233.39 gram per mole. Atomic weight of barium is equal to 137.33 gram per mole. Therefore, amount of barium is equal to 137.33 divided by 233.39 into weight of barium sulfate. If the sample contained a barium chloride or other barium salt, convert accordingly. Calculation formula. First one, mass of barium from barium sulfate. Mass of barium is equal to mass of barium sulfate into 137.33 divided by 233.39, where 137.33 is equal to atomic weight of barium, 233.39 is equal to molecular weight of barium sulfate. Second one, amount of barium sulfate formed. Mass of barium sulfate is equal to W2 minus W1, where W2 is equal to weight of crucible plus barium sulfate. W1 is equal to weight of empty crucible. Percentage of barium is equal to mass of barium divided by mass of sample into 100. Calculation formula. Third one, barium in sample. Percentage of barium is equal to mass of barium divided by mass of sample into 100. Fourth one, if sample contains barium chloride, mass of barium chloride is equal to mass of barium sulfate into 208.23 divided by 233.39, where 208.23 is equal to molar mass of barium chloride, 2H2O common hydrated form. And fifth one, barium chloride in sample. Percentage of barium chloride is equal to mass of barium chloride divided by mass of sample into 100. Result, the percentage or amount of barium or barium compound in the given sample is calculated based on the mass of barium sulfate is obtained. Diagram of determination of barium has barium sulfate gravimetric method. First one, precipitation, second one, filtration, and third one referred to ignition. Key steps. First one, precipitation. Barium plus sulfate is equal to barium sulfate. Second one, digestion. The hot mixture is allowed to stand so crystals become larger and purer. And third one, filtration and washing. Precipitate is filtered and washed to remove impurities, especially chlorides. And fourth one, drying and ignition. Barium sulfate is heated to constant weight at a high temperature. And fifth one, weighing and calculation. The mass of barium sulfate is used to calculate the amount of barium ions in the sample. Summary of this topic. The gravimetric determination of barium involves precipitating barium ions from a solution by adding a sulfate reagent, usually dilute sulfuric acid. This forms barium sulfate, an insoluble, stable and heavy precipitate. The barium sulfate precipitate is then heated, filtered, washed, dried, ignited and weighed. Because the chemical composition of barium sulfate is known, its mass can be used to calculate the exact amount of barium in the original sample. Precautions. First one, avoid excess H2SO4 to prevent colloidal precipitation. Second one, wash thoroughly to remove soluble impurities. Third one, handle the barium sulfate precipitate carefully to avoid a loss. And fourth one, cool in the desiccator before weighing. Conclusion. In this experiment, barium ions present in the sample were successfully determined by precipitating them quantitatively as barium sulfate. The precipitate obtained was washed, dried, ignited, cooled and weighed to constant mass. Since barium sulfate is highly insoluble, stable and heavy, it allowed accurate gravimetric measurement. From the final constant weight of barium sulfate, the amount of barium present in the original sample was calculated using stoichiometric relations. Thus, the gravimetric method proved to be precise and reliable technique for estimating barium content.